In this lesson, we're going to take a look at the parabola, and I'm going to bring up a few documents. I'm going to go into lecture notes, and in lecture notes, we're going to take a look at, it's actually chapter 6 in the lecture notes, but it's module 5 for our class. And we're going to take a look at section 6.1. I've also listed a video on completing the square, because completing the square will be a skill that would be utilized in this last module 5. All right, so I'm going to click on section 6.1, and I'm actually going to go down to just talk about the conic section for a little bit. And in the conic section, we have the following. We have parabolas, circles, ellipses, and hyperbolas. In this particular course, we're going to deal with parabolas, ellipses, and hyperbolas. So here's the setup. We basically have two cones that are intersected by a plane or by planes, and they produce the following shapes. So if we look at the first set, okay, we have a cone that's intersected by a perpendicular plane. So notice that the form that it shapes is a circle. If we were to take the plane and we were to slant it slightly, we get the form of an ellipse. And so that elliptical shape is actually the intersection of the plane and the cone. Notice for a parabola, if we slant our plane a little more, right, notice we have a parabola shape. And then lastly, if there is a 90-degree intersection with our plane, notice it forms a hyperbola. So we're going to start off by talking about a parabola. And here is the definition of a parabola. A parabola is a set of points in a plane equidistant from a fixed point and a fixed line, right? So equidistance means that it's the exact same distance. The fixed point is called the focus, and the plural of focus is foci, and we're going to talk about the foci when we go a little bit further and talk about ellipses and hyperbolas. But for a parabola, we have a fixed point that's called a focus, right, which is here. And we have a fixed line, which is called the directrix. So this is what actually makes a parabola a parabola. If we were to measure the distance from the focus to any point on our line, right, let's say this point here, if we were to put a ruler on it, we would get some measurement. We would get the same measurement from the point to the directrix. Okay, so these two distances are the same. So notice that it says the distance from P to F. So P would be the point on our curve to the focus point. That's equal to the distance from the point on our curve to the directrix. So this is what makes a parabola a parabola. Now we have two types of parabolas. We have a parabola with, well, we have parabolas with vertical axes, and we have parabolas with horizontal axes. First, we'll look at the parabolas with vertical axes. So here we have that the parabola with the focus 0, comma C. Now the notation from our book, instead of C, it uses P. Right, so the focus is going to be from 0. Well, the focus coordinates are located at 0, comma C, and the directrix is y is equal to negative C, and it has this equation x squared is equal to 4cy. Now I'm actually going to just pull up OneNote here. Okay, I'm just going to rewrite the formulas, and I'm going to use the variable P instead of the variable C. So now this is the basic setup for a parabola. So I don't know how many of you all are familiar with a satellite dish, but let's just say we have a satellite dish. Okay, and on all satellite dishes, we have a receiver. Okay. So the basic premises for a satellite dish, it works off a parabola. So this U shape we see here is actually the shape of a parabola. So let's just say we have a satellite in the sky, and that satellite is giving off waves. All right, it's giving off the signal. So how it works is once the signal hits the parabola, the way the parabola is designed, the receiver is actually the focus point. So all of the signal goes to our focus point. So this is why the focus is an integral part of a parabola. All right, so let's take a look at some model forms. So here we're going to look at parabolas with a vertical axis. Okay. And we're going to start off with the shapes. So here we have a x and a y axis, right? And we have a basic parabola, right? So if your parabola is U-shaped, the model form you're going to use is x squared is equal to 4py, right? So notice that on the right hand side of our equation, 4 is a constant. So just remember, a constant is a number. P is also a constant, right? So there will be a value for P when we actually write out our equation. And then we have Y, and Y is a variable. All right, so 4 times P, that actually gives us a constant number. Okay, so this is our model form for a U-shaped parabola. The vertex is located at 0, 0. Now there's two sets of formulas that we're going to deal with. We're going to deal with conics that are centered at the origin, right, which is what we have here. And then we're going to look at conics that are not centered at the origin, and there's an entirely different set of formulas for those conics. But here we're going to look at the most basic forms, right? So next we have the focus. Now remember, the focus point is actually the receiver on our satellite dish. So our focus point is going to have the coordinates 0, comma p. Right? So if I were actually to plot this out, right, I'm starting at the origin. I'm not moving to the right. I'm not moving to the left. I'm going to go up, right, a distance of p units. So that's our focus, 0, comma p. And notice we must also have a directrix. Right? So I'm going to just call that directrix D. So the directrix is actually a horizontal line, and that horizontal line has an equation, and that equation is y is equal to negative p. All right, so knowing p, well, first of all, knowing the shape of your curve is important. Also knowing p, right? If you know p, you can pull out the coordinates for the focus and also the directrix. All right, so let's look at the other model form for parabola with the vertical axis. right? So here again, we have an X and a Y axis. Okay, but this time our parabola is an upside down U shape. So if your parabola has an upside down U shape, here is the model form. X squared is equal to -4 times P times Y. So notice that the coefficient of your Y variable would be negative. And notice that for each one of these formulas, we have isolated for X squared. So when you're asked to put your equation in standard form, only the squared term should be on the side of the equation by itself, and the coefficient of the squared term must be 1. All right. So this is the model form for an upside down U-shaped parabola. So we're going to pull out the vertex. So again, these parabolas are centered at the origin. We're going to pull out our focus point. So the coordinate for the focus is going to be 0, -P. And for our parabola, we must have a directrix. So the equation for the directrix is y is equal to P, right? Now we determine which model form we use based upon the variable that's squared. So on a parabola, only one variable is squared, right? So we look at the variable that's squared, and then we look at the sign of our other variable, okay? So let's take a look at an example. All right, so here we're asked to find the focus, the directrix, and the vertex and the axis for x squared is equal to 8y. All right, so here's our first example. Find the focus, directrix, vertex, and axis for x squared is equal to 4ay. Right? So the first thing you must do is choose a model form. All right, so if we look at x squared is equal to 4ay, notice that the x variable is squared, and notice that the coefficient of y is positive. So that means that we're going to use this first model form. All right, x squared is equal to 4py. Right, so the first thing we're going to do is we're going to find, excuse me, that should be x squared is equal to 8y. So this is the model form we're going to use. X squared is equal to 4py. So I'm going to use something called a transitive property. And the transitive property says if A equals to B, and I'm going to write that down here. It says if A is equal to B, and B is equal to C, then A is equal to C. All right, so what does that mean? Well, I'm actually going to use my model form to find P. And I'm going to use that transfer property. So this is what the transfer property says. If A, which is x squared, is equal to B, and if A is equal to C, I can set B and C together. All right, so I can let 8y equal to 4py. All right, so if x squared is equal to 8y and x squared is equal to 4py, I can set 8y equal to 4py. And now I'm going to solve it for p. All right, so in order to solve for p, the opposite of multiplying 4y times p would be to divide by 4y, right? So 8y divided by 4y, my y's are going to cancel. 8 divided by 4 is 2. And on my right hand side, the 4 and the y are going to be canceled. So I have p is equal to 2. So now once I found p, I can substitute p into the vertex, focus, and directrix. All right, so well, first of all, the focus is going to be, the vertex is going to be 0, 0, right, because it's centered at the origin. The focus is going to be 0, comma p, right, and p is 2. The directrix it has the formula y is equal to negative p. So the directrix is y is equal to negative 2. And this has a vertical axis of symmetry. Right. Now, if we go back to, all right, this example, right, this is actually x squared is equal to 8y. All right, so notice that once we found, and this is why you'll see in the solutions on the homework, they'll factor out 4, because this model form is x squared is equal to 4py. So if you factor out a 4, 4 times 2 is 8, right? So our focus is 0, comma 2. The vertex is 0, comma 0. And then the equation for the directrix is y is equal to 2. Or excuse me, y is equal to negative 2. All right, we're going to take a look at another example. And here we're asked the same thing. Find the focus, directrix, and the vertex for y is equal to 1 over 28x squared. Okay. So first off, we have to find a model form. So in order to find your model form, the first thing I notice is that my x variable is squared. Since my x variable is the only variable that's squared, there's two possible model forms. Right? X squared is equal to 4py and x squared is equal to negative 4py. So the model form we're going to use is x squared is equal to 4py. The first thing I'm going to do is put this in standard form. Okay, so put it in the standard form just simply means I must isolate for the squared term. So I'm going to isolate for x squared. So the opposite of multiplying x squared by 1 over 28 would be to multiply both sides by 28. So I'm kind of want to flip this around. So I have 1 over 28 x squared is equal to y. I'm going to multiply both sides by 28. Right? Because whatever you do to one side, you must do the exact same thing to the other. So on the left-hand side, the 28's cancel. I'm left with x squared. And on the right-hand side, we have 28y. Now, one thing I noticed is that in the homework set, sometimes they want you to factor out a 4. Right? So we can kind of isolate the value for p. So we can write our standard equation form as either x squared is equal to 28y or x squared is equal to 4 times 7 times y. Okay, so in some instances, you can write it out as simply x squared is equal to 28y. In other instances, you can write it out as x squared is equal to 4 times 7 times y, but both solutions are the same. So now that we have it in standard form, we're going to pull out the focus, the directrix, and the vertex. All right. Okay. So notice that we factor out a 4, p is going to equal to 7. Okay. And again, we can find p by using that transitive property. So I'm going to put another step in. We're going to find p, right? So we're going to take x squared is equal to 28y. And we have our model form. X squared is equal to 4 times p times y. So I'm going to set 28y equal to 4py using that transitive property. In order to solve for p, I'm going to divide both sides by 4y. On the left-hand side, I have 7. And on the right-hand side, I have p. So now we have the vertex is 0, 0. The focus is 0, 7. The directrix is y is equal to -7. Okay. All right, now we're going to look at parabolas with the horizontal axis. So for parabolas with the horizontal axis, And we have two types. So we have a C shape. Okay. So if your parabola is C-shaped, it's going to take this model form. Y squared is equal to 4px. So notice that the y variable is squared and the coefficient of our x variable is positive. So that's going to produce a C shape. The vertex is 0, 0. The focus is given as p, 0. And our directrix is given as x is equal to negative p. All right, so this is the model form in which the y variable is squared and the coefficient of the x variable is positive. The other model form is the reverse C shape. So if we're given this as a graph, the model form is x squared is equal to negative 4px. The vertex is 0, 0. The focus point is negative p, 0. And the equation for the directrix is x is equal to positive p. All right, so here are the two model forms for parabolas with horizontal axes. All right, so let's take a look at an example. So we have y squared is equal to negative 28x, and we're going to find the focus, the directrix, and the vertex. So in this example, we're asked to find the focus, directrix, and the vertex for y squared is equal to negative 28x. So first we have to find a model form. So I see that my y variable is squared and the coefficient of my x variable is negative. So I'm going to use this model form. Y squared is equal to negative 4px. So notice that this is already in standard form because the coefficient of our squared variable is 1. So we are going to find p. Right? So if y squared is equal to negative 28x, and if y squared is equal to negative 4px, we can set negative 28x equal to negative 4px. So now we're going to solve for p. So I'm going to divide both sides by negative 4x. So on the right hand side, the x is canceled. A negative divided by a negative is a positive. So 28 divided by, well, negative 28 divided by negative 4 is 7. On the right hand side, we're left with p. So 7 is equal to p. So now we're simply going to substitute 7 for p, right, in this model form. All right. So we have that the vertex is 0, 0. The focus is negative p comma 0. So we know that p is 7. So the focus is negative 7 comma 0. And the directrix is x is equal to 7. All right, so you simply choose your model form, solve for p, and substitute p into your formulas. All right, so we take a look at y is equal to negative 28x. We see that the focus is negative 7 comma 0. We can see that the vertex is at the origin 0 comma 0. And we can see that the equation for the directrix is x equal to 7. Now we'll take a look at another example. So this is example 4. And we have x is equal to 1/8 y squared. All right. Well, let me write the directions. Find the focus directrix and the vertex for x is equal to 1/8 y squared. So the first thing we're going to do is put it in standard form. So the first thing we're going to do is put in standard form. Right, so we're going to isolate for y squared. So I'm simply going to multiply both sides by 8. So we have y squared is equal to 8x. Right, sometimes you may be asked to factor out a 4, right, on that right hand side. So we can write this as y squared is equal to 4 times 2 times x. And notice when you factor out 4, you actually are finding p. Right? So the second thing we're going to do is we're going to find p. Right, so we have y squared is equal to 8x. We have our model form, which is y squared is equal to 4px. So we're going to set 8x equal to 4px. We're going to solve for p, so we're going to divide both sides by 4x. So 2 is going to equal to p. So now we're simply going to substitute P into the equations for that model form. So we have the vertex is 0, 0. We have the focus as 2, 0. We have the directrix as x equal to -2. All right, and these are for parabolas that are centered at the origin. Now, just for reference, I'm going to go back to the course and I'm going to go into formula sheets. And in formula sheets, there is the all exam formula sheet. And on the last page, right, notice we had a conic section. Okay. So we basically looked at these formulas for the parabola, and I have just changed the variable. On this formula sheet, the variable is A, but this textbook uses the variable P. All right, so here's where you can find the conics, the formulas for the parabola. If I go back into the formula sheet section, you'll see there is a separate handout that says conics. Okay, I'm going to click on that. And what we have here are the formulas for the all right, and what we have here are the formulas for the conics that are not centered at the origin. All right, so let's take a look at this particular formula sheet. I'm going to go back 1 second. Go back into conics. Okay, here we are. All right, so if we take a look at this first formula, so notice that if this were at the origin, it would be x squared is equal to 4py. Since this parabola is not at the origin, it has a different formula. Notice that h follows the x variable, k follows the y variable. All right, so for this particular model form, we have x minus h quantity squared is equal to 4p times the quantity y minus k. So in our formulas before, since h and k were 0, we simply had x squared is equal to 4py, right? Because y minus 0 is y. Since we have coordinates that are other than, well, since we have the vertex, which is something other than 0, 0, we have to account for that. All right. So notice that the vertex for this model form is h, k. The focus has the formula h, k plus p. Right. So it's no longer just p. Like it's no longer zero comma p, it's actually h comma k plus p. So we have to know the values of h, k, and p in order to find the focus. We also have the directrix. The directrix is y is equal to k minus p. All right, so we must take the y coordinate of our vertex minus p. Okay, we're actually going to use these in a second, but I want to just guide you on what's going on with our formulas. And then we have the second formula, which is for a horizontal axis, and we have y minus k quantity squared is equal to 4p times x minus h. So notice that if this were centered at the origin, we would simply have y squared is equal to 4px. But since our vertex is not at the origin, we must account for our vertex. So notice that h must always follow x. Right? So notice over here, h follows x. And then k must always follow y. Right? Because when we write out our vertex, the vertex is still h comma k, but you must be careful when you situate your vertex within your equation. The focus has the formula h plus p comma k, and the directrix has the formula x equal to h minus p. Right? So again, we have to know the values of h, k, and p. So now we're going to take a look at an example. So this is example number 5. We're asked to rewrite the given equation in standard form, and then we have to determine the vertex, the focus, and the directrix. Okay, of the parabola. So we have y squared plus 2y minus 32x plus 65 is equal to 0. Okay. So the first thing we must do is find a model form. So when I'm finding a model form, notice that for a parabola, only one variable can be squared, never both. So in this case, only the y variable is squared. So I know it's either going to be one of the two horizontal axis formulas for our equation. So I'm actually going to have to complete the square for this particular problem. So I'm going to write this out as, or first I'm going to somewhat put it in standard form. So we have y squared plus 2y. And then I'm going to add 32x to both sides. And I'm going to subtract 65 from both sides. Because I actually want to isolate my y variables since my y variable is squared. The next thing I want to do is I want to complete the square. So at this point, I just want to guide you to this particular video. So if I go back into the course, and if I go into lecture notes, okay, there is a video on how to complete the square, which is what we're about to do in the next step. Okay, so if the next step is unclear, you may want to go back into the lecture notes section and watch this complete the square video. So now since I have y squared and my y variable isolated, okay, so remember, whatever you do to one side, you do to the other side. So when I complete the square, I'm going to add some quantity to the left-hand side. I must also add that same quantity to the right-hand side. So in order to complete the square, we want to take half of the coefficient of our middle term. So the coefficient of our middle term is 2. I'm going to divide that in half. Right, so I'm going to divide by 2, and then I'm going to square it. So 2 divided by 2 is 1, and 1 squared is 1. Since I added 1 to the left-hand side, I must also add 1 to the right-hand side. Okay, so that's completing the square. Right, you take half of the coefficient of the middle term, so half of 2 is 1, and then you must square it. Whenever you complete the square, you force a perfect square trinomial. So that means that y squared plus 2y plus 1 is actually a perfect square trinomial, and that can be written as y plus 1 quantity square. Right? Because if I take y plus 1 times y plus 1, I'm going to get y squared plus 2y plus 1. All right, so that happens every time you complete the square. That's equal to 32x minus 64. Right, because negative 65 plus 1, I can combine like terms. Okay, these things are both constants, and I get negative 64. The next thing I'm going to do is I'm going to factor out a 32. Well, just to show where this is headed, I'm going to factor out a 32 on the right-hand side. So if I were to factor out a 32, in the set of parentheses, I'm going to have x minus 2, right? Because if I go back and actually check by multiplying, 32 times x is 32x. 32 times negative 2 is negative 64. And this would be standard form. Or we can write this as y plus 1 quantity square is equal to 4 times 8 times x minus 2. Right? Because here 4 times 8 is 32. So I just factored out a 4. Right? So from this I can realize that P is 8. All right, so this is our standard form. So now before we go further, there are some things that I need to know. I know that P is equal to 8, and then our vertex. So remember, our vertex is in the form H comma K. So our vertex is going to be 2 comma negative 1. So H is equal to 2 and K is equal to negative 1. Right, so now here's some things I want to point out. So I'm going to concentrate on this. All right, so this is standard form. And I just want to show what's going to happen with the vertex. The vertex, the signs will change once you take the vertex out of your equation. Okay, just let me show you why really quick. I'm going to go back into our formulas. So notice if we look here, right, we have y minus k quantity squared is equal to 4p times x minus h. Right, so this is our model form. So notice in this model form, we have y minus k quantity squared is equal to 4p times x minus h. Okay, so this is why your vertex will change. Right, so we have the model form y minus k quantity squared is equal to 4p times x minus h. So we have the vertex is 2 comma negative 1. So h is 2, k is negative 1, and we have p is 8. So I'm going to substitute those things into this formula. So h is equal to 2, k is equal to negative 1, and p is equal to 8. So we have y minus, right, because this minus is a part of our model form. K is a negative 1. So I have to make sure I substitute in negative 1 squared. That's equal to 4 times p, right? And p is 8 times x minus, right? And I have to include the minus because that's a part of our formula. And h is 2. So now if I simplify, I'm going to get y plus 1 quantity squared is equal to 32 times x minus 2, which is the same thing that we have here. Okay. So with that being said, you must change your signs when you take your vertex out of your equation. Okay. All right, so notice when we wrote our equation, we had y plus 1, but I had to change that plus 1 to a negative, and I had to change x minus 2, my h, to a positive 2. Because we're going to need these three things. Okay, so now we're going to take p is equal to 8, h is equal to 2, K is equal to -1. And we're going to find the vertex. Okay. So we already have the vertex as 2, -1. Now we're going to find the focus point. So now how do I find the focus point? Well, I'm going to go back to our formula sheet, right? And we're going to use this formula. So notice that the y variable is squared and the coefficient for our x variable is positive. So here it says that the focus has the equation h plus p comma k. So I know that h is 2, k is -1, and p is 8. So h plus p, that's going to be 2 plus 8, and k is -1. So our focus is located at 10, -1. All right. Next, we're going to find the directrix. So if we go back to our model form, the directrix is h minus p. Well, x is equal to h minus p. X is equal to h minus p. So I know that h is equal to 2, p is equal to 8, so x is equal to 2 minus 8. So our directrix is x is equal to -6.